Good morning. This is Kasturi Day. Today I am going to discuss the electricity and magnetism chapter question answer series. It is the short and long question answer. It is the continuation of that series. Okay. So let me start with the first one. Name two factors on which the strength of magnetic field of an electromagnet depends. It depends on the number of turns of the wires within the coil and the amount of current which is flowing in the coil. So if you increase the number of coils or turns of the wire within the coil, it can increase the magnetic strength, and even the amount of current, if we increase, then it will also increase the magnetic strength. Okay, so what is the magnetic declination? Draw a diagram to show the angle between the declination and the true direction of geographic north. So when we place a magnetic needle just on the earth, like in a open field, if we place, we will see that it is pointing slightly. This deflection, that's you know that the magnetic needle will settle some, it will swing for some time and then it will settle in a direction, in the north-south direction, okay, in a particular north-south direction. So if we see that direction which the magnetic needle settles down is slightly away from the actual geographic north-south direction. So this angle, this deflection, this from the actual geographic north to the north-south direction which the magnetic needle is pointing, it makes an angle with that, these two. If we draw a line in the geographic north-south direction and the this magnetic needle magnetic north-south direction, if we draw a line, we'll see that the geographic north-south direction and this magnetic north-south direction forms an angle, okay, which is denoted by symbol theta. This angle is known as angle of declination. Okay, and this differs from when you go from one place to another on the earth's surface. Okay, and if this declination is towards the east of the true geographic north, then it is positive. This declination is positive. And if it is, if this magnetic north-south direction is slightly towards the west of the north-south, actual north-south direction or geographic north-south direction, then it is slightly, and then the value of this declination, that is theta, that will be negative. Okay, so this magnetic declination is the angle of the horizontal plane between the magnetic north and the geographic north or the true north. The angle is denoted by symbol theta. The angle of declination is different at different places on the earth's surface, and it also changes at a place with time. The declination is taken positive if the magnetic needle is towards the east of the true north, and is negative if the magnetic needle is towards the west of the true north. So this is the diagram which is representing the declination. Okay, this is the earth, this is the geographic north-south, this is the geographic north, and this is the magnetic north. So if we draw a line, this is the 180 degree. If we draw this 180 degree, and if this is the magnetic needle, this will form an angle. Okay, this is denoted by this symbol. And if it is towards the east, then the theta will be positive. And if this magnetic north is towards west, then the theta will be negative. Okay. Then describe an experiment to show that electricity flows only if the circuit is complete and it does not flow if the circuit is incomplete. For this, let us take a cell, two wires, there's one and two wires, and a bulb. Okay, now the cell has two ends, that is, one is X, one is Y. This is positive, this is negative. Okay. Now, if we join this X, that is the positive end, with the bulb, and also the negative end with the bulb, we will see the current will start flowing and the bulb will be glowing. Okay. That is, the current is flowing from the X terminal through the one wire into the bulb, and from the bulb it comes to the Y terminal. So the circuit is complete. Okay, therefore the filament of the bulb glows. Now in the second case, if we break this one wire, if we break this wire, which we are not joining with the bulb, okay, the terminal is connected to the X. This one wire is one end is connected to the X, but the other end with the bulb has been broken. Okay, and the other wire which is connected to the bulb as well as with the Y terminal, that is intact. So one end of the one wire is broken. Okay, so here we see the bulb is not glowing. This shows that the circuit has been broken, the circuit is not complete, and therefore the bulb is not glowing. Okay, so for this we need to take a 1 meter long plastic or insulated metal wire, then cut the wire into two halves by means of a blade and remove the plastic covering at the ends of each wire. Let us take a torch bulb and with the help of a sellotape fix one end of each wire to the terminal of the bulb, the other to the cell. Okay. Then let us fix the other ends of the wires to the terminals X and Y of the cell. These X and Y terminals of the cell are the electrodes. One is cathode and the other is anode. Then when we will observe that the bulb gets lighted. Therefore, the electricity is flowing into the wires through the bulb. And therefore the electricity flows from the terminal marked X of the cell, that is anode, to the bulb along the wire labeled 1, then through the filament of the bulb, and then through the wire labeled 2 to the terminal Y, that is the cathode. Okay, this is the total circuit. Now the bulb will glow, that is the circuit is complete or closed circuit. Then let us remove the wire 1 from the bulb connected to the terminal X of the cell. We will observe the bulb will not glow. Now, therefore, no electricity is flowing through the circuit. Okay. And when we will observe, the bulb will be not glowing and the circuit is then incomplete or open. So from the above experiment, we conclude that electricity flows only if the circuit is closed or complete, and the circuit will stop flowing if the electricity will be stopped flowing if the circuit is open or broken or incomplete. Okay. Now, next question, in which of the following cases the bulb will glow only one terminal? First case is only one terminal of a cell is joined with a metal wire to one terminal of the bulb. Then both the terminals of the bulb are joined with the two metal wires to one terminal of the cell. Then one terminal of the cell is joined to one terminal of the bulb and the other terminal of the cell to the other terminal of the bulb. Okay. So the case will be the third one where the circuit is complete. Okay. Now next is coming to select conductors and insulators from the following: glass, silver, copper, wood, paper, pure water, impure water, aluminium, iron, leather, plastic, steel, human body and ebonite. Conductors are silver, copper, impure water, aluminium, iron, steel, human body, whereas insulators are glass, wood, paper, pure water, leather, plastic and ebonite. Okay, now the following diagram shows 4 circuits A, B, C and D. Each circuit has a cell and a torch bulb. Name the circuits in which the bulb will glow. Give the reason to your answer. So, the first case, see, 2 wires are there, 2 metal wires, copper and aluminium both are metal. So, this is a 2 wires are metal, there's a cell and the bulb. Here, the wires are made of, one is made of silk, one is made of copper, and there's a cell and a bulb. In the third case, the C case, there are the two wires which are made up of silk, one is cell and then the bulb. And the fourth case, D, the two metal wires, copper, the two wires are made up of copper, cell and bulb. So in the first case, that is A and D case, the wires are made up of metal. So the metal are good conductors of electricity. So the current will be flowing and the circuit will be complete. So therefore the bulbs will glow in case of A and D. For B and C, for B, one is made of silk and one is copper. So B is a good conductor, whereas silk, that is one wire is, which is made up of copper, that is a good conductor, whereas silk is an insulator. So the current will not flow because the circuit is not complete. And in the third case, the C, there are two wires which are also made up of silk. Their silk is an insulator, so therefore no current will flow through, no electricity will be flowing through, and therefore it will not glow. Okay, next, the diagram below shows a bulb connected with the cell having the terminals A and B mark the direction. So the current will be flowing from the positive terminal this way. This is the positive terminal signal sign. So this will flow, current will flow like this. Now state the function of each of the following of the electric circuit and draw its symbol representation, switch and the cell. Switch open, switch or the key is used to put the circuit on and off. So switch open will be like this. This is the switch open symbol, and or you can say like this, okay? Or switch closed will be like this, closed circuit, or this will be with a full stop. So cell is generally used as a source of electricity. Cell is denoted like this, positive terminal with a big long arm and a small arm, thick small line, that is with negative terminal. Then in which arrangement are the appliances connected in the electric circuit of our home, series or parallel? It is connected in parallel. Give one reason for your answer. Because when the circuit is in parallel, the appliances work independently. Okay. So every appliance when put on works on its own without interrupting the other appliances. In our homes we can see that each electric appliance work independently without interrupting any other appliances. When we switch on tube light in a room, so only that tube light will be on, the fans will be switched off. And if they were connected in series, we have to make all the appliances on, then only the current will flow through. But in parallel connection, one electric current, the tube light, if it is on, the fan has not to be, it's not needed to switch on the fan to put on the circuit. Okay, switch on the circuit like this. Okay, then state the two precautions that you must take when switching on an electric circuit. See that all the components of the circuit are properly connected and do not touch the switch or any component with wet hands. Okay. So I have completed this total electricity and magnetism chapter according to ICSE syllabus class 7. Okay. Now in my next video, I'll start with class 8 syllabus. Okay. So if you have any doubt, please do write me in the comment box. And you can also give suggestions to improve my videos. Okay. And if you like the video, press the like button so that I can produce you more enthusiastic videos that you can like it much better. And if you are a new viewer to my channel or not subscribed yet, please do subscribe to get the notification of my next video. Thank you.